Hi, what we're going to do today is we're going to find the slope as a rate of change from equations, patterns, and pictures. So on problem number 1, it says Mrs. Jenkins used 30 pounds of hamburger meat to make sloppy joes for the football team dinner. She scooped the same amount for each sandwich. Each scoop was equal to 1/2 pounds. A linear model is represented by the function. So 30 minus 1/2 per scoop will figure out how many scoops she's going to be able to scoop for with 30 pounds. So on 1A it says, what is the rate at which Mrs. Jenkins scooped out the sloppy joes? Well, it would be 1/2 pounds per scoop. That's the rate per one unit, per one scoop. What is the 30 in this relationship? It's not the number of scoops, it's the starting amount of hamburger meat. That's it. It's not the total number of players. It's not the amount of hamburgers left. How many sandwiches could be made from the 30 pounds of sloppy joes? Well, if you think about it, if she was scooping out 1 pound per sandwich and there were 30 pounds, it would be 30 sandwiches. But she's getting twice as much. She's scooping just a 1/2 pound. So that means she's going to get double the amount of sandwiches. So that would give us 60 sandwiches. All right, let's take a look at problem 2. This equation relates to the amount of money Karen saves each week. So you have S equals 10W plus 75. What is the rate at which Karen is saving money each week? It's $10. If there's a variable with that number, that is going to be your rate always. So she has a what rate at which Karen's saving money in each week. It's going to be $10 per week. What is the y-intercept in the relationship, and what does it represent? It's 75, and it's going to represent the beginning amount or her starting amount. That's what she had in her savings account. Then 2C says, how much money would she have in the bank after 12 weeks? Well, you could go 10. Whoops, why did I do that? Okay, let's try the skip. 10 times 12 is 120 plus the 75. So 120 plus 75 would be $195. And how many weeks would it take her to save $375? So what you would do is you would take that 375 and you're going to put it in place of S right there. So 375, so it would look like 375 equals 10W plus 75. So if you subtract 75 from both sides, that gives you 300. Okay, so then it's going to be 300 divided by 10. So 300 divided by 10, 30 divided by 1 is $30. How many weeks would it take her to save, not $30, but how many weeks would it take her to save $375? It would take her 30 weeks. Okay, so that's quite a few weeks. And 2E says, what would be a new equation if she adds 3 times as much money to her account each week? So instead of adding $10 per week, she's adding the $30 per week. So the new equation would be S equals 30W plus 75. Her starting amount is still the same. Okay? All right, let's go on to the next one. 3A, your parents bought you a meal. Oh, wait. You know what I forgot to do? Forgot to fill in this table here. So 0 would be 75. And then after the first week, of course, you're just adding $10. So that would be 85. And each week after that, you're still just adding $10. So this would be 95, 105, 115, and so on. And again, another thing that you could do is you could put this equation into your calculator. Remember, you go and create a new, you go to graph, you plug in this. And remember to always use X. Don't use W when you're putting that, or another variable, when you're putting that into the calculator. And then you hit enter and it will show you the graph. And then you can hit Control T for the table. And there you have all your documents and numbers that you want. All right, let's go on to 3A. It says your parents bought you a meal ticket for college with $300 on it. Each meal you buy costs $6. Which of the following equations models the amount of money A on the card after you have purchased N number of meals? So there's $300 on it to begin with, not $300 per purchase or anything, a flat $300. So that is a positive 300. So right here, that's negative 300. So we're going to X that out. And this has 300 per N, which is the number of meals. Can you imagine spending $300 per meal? That is not the situation there. All right, so let's go here. Now, it says each meal you buy costs $6. Well, that's just like having a regular, like you have a Starbucks card or whatever, and each time you use it, it doesn't add that amount to the card. It takes away. So the answer would be letter G. So they start with 300 and they're taking away $6 per meal. All right, let's look at 3B. Use your equation from 3A to find out how many meals you have purchased when you have $180 left on the meal ticket. So what you're going to do is you're going to put 180 equals negative 6N plus 300. And so I would subtract 300 from both sides here. Negative 6N equals, and 300 basically minus 180 gives you 120. It's a negative. You divide by negative 6. So 6 goes into 12 two times, and then you have the 0. So N equals 20 meals. Another thing you could do is, of course, put that equation into your calculator, graph it, hit Control T so that you can find your table of values, and you can go down and find out. So you have an x-axis and a y-axis. So you would scroll along the y-axis until you see 180. And then that would be 20 right there. Okay. All right, let's go ahead and take a look on the back side. Now we have patterns in the nth term. When given a pattern, make a t-chart like the one to the right. Find the nth term. So on problem number 4, it says, which of the following expressions could be used to find the perimeter of the nth set? So we have 3 sets, 1, 2, and 3. And the perimeter is the distance around. So we have 1 length, 2, 3, 4, 5, 6. And then on 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So then what we could do is we could go ahead and plug these numbers in place of N into each of these rules. So let's just start with 1. 1 plus 4 equals 5. We need it to equal 6, so it's not that one. And then letter B, 4 times 1 is 4 plus 2 is 6. Well, that looks like it could work. Let's try 4 times 2 is 8 plus 2 is 10. That works. And then 4 times 3 is 12 plus 2 gives us 14. So this is going to be our rule. Another thing is you could go ahead and put these into your calculator and hit enter so it graphs it, and then do a QT for the table. And then you could just look to see if the table of values matches your value over here. All right, let's go ahead and take a look at problem number 5. It says a tower currently has 4 levels. If the pattern continued, which of these expressions would find the number of total blocks needed for any level. So this is a total number of blocks needed for any level. So we've got the level numbers, which there are 4. Okay, and it does say count the levels from top to bottom. So level 1, 2, 3, 4, and this would be the total number of blocks. So total blocks here. So on level 1, we've got 1 block. On level 2, we've got 1, 2, 3 blocks. On level 3, we've got 1, 2, 3, 4, 5 blocks. And level 4, we've got 1, 2, 3, 4, 5, 6, 7 blocks. So then we're going to do the same thing we just did on problem number 4. Is we're going to plug each of these values in and see if it gives you the total number of blocks. So if we start with 1, 2 times 1 is 2, minus 1 is 1. So that works. Let's try this one. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. And 2 times 4 is 8, minus 1 is 7. So that one actually works right away. Okay, let's go ahead and take a look at now from pictures. We're going to find the rate of change from pictures. Let's look at problem number 6. What is the slope of the 13-foot ladder as it leans against the building? All right, remember slope is rise over run. So we're never ever going to use this slant. So it would be 5 over 12. All right, let's try to pause this for a minute. I needed a drink of water. It's not going to let me pause. Okay, let's go on to... All right, so on problem number 7, it says, what is the slope of the 10-foot ladder as it leans up against the building? Again, we're never, ever going to use the slant when we're calculating the slope. So it's rise, which is 9, over run, which is 3. So this would be 3 feet. All right, problem number 8. What is the slope of the ramp as it ascends into the air? Again, we're never, ever going to use that slant. So it's rise, 134, over run, 500, and that actually reduces to 67 over 250. All right, and the last one on number 9. What is the ratio of rise to run as the airplane... wonder what that was supposed to say. What is the ratio of rise to run? I guess as it ascends or descends, or I guess it would be ascending. All right, so we're going to put our rise, which is 150, over our run, which is 500. And to reduce that, I can cancel out the zeros, and 15 divided by 50 has 5 in common. So 15 divided by 5 is 3, and 50 divided by 5 is 10. So it would be 3/10. All right, hope you enjoyed the video. Sorry it took a little bit long. I can't seem to get this to stop.